In this video, we will learn about achievements of Mendeleev's periodic table. The first one was systematic study of the elements. So Mendeleev's periodic table actually generalized the study of the then known elements into the study of mere 8 groups. So it was very easier to study them. Mendeleev's periodic table made the study of elements and their compounds easier because knowing the properties of only one element in a group, we will already get to know the properties of other elements in the group. So these properties can actually be predicted since all the properties, basically since all the elements in a group have similar properties. Then he also predict some new elements. So he left some vacant spaces in his table for elements that were not yet discovered. The greatness of Mendeleev is that he predicted properties of some such elements and their compounds. So Mendeleev actually used the prefixes eka, div and 3, basically from Sanskrit words for 1, 2 and 3, whether the predicted element was 1, 2 or 3 places down from the known element in his table with similar chemical properties. Three such elements were, the first one were Eka boron, Eka aluminium and Eka silicon. Eka boron means an element 1 place down boron in the group. These three predicted elements were discovered during his lifetime, which were named as scandium, gallium and germanium respectively. The properties of Eka aluminium predicted by Mendeleev and those of the elements gallium, which was discovered later in 1875 and actually replaced by Eka aluminium, are given to. So atomic weight, this was the property which was given by Mendeleev, which is 68, and the gallium's actual property, actual atomic weight was approximately 69.7, so which is almost equal. Then you also told about the density of Eka aluminium, which was 5.9, and gallium has density of 5.9. It just told that the melting point is going to be low, and yes, that was low, which was around 29.7. Then he exactly told the formula of oxide, which was R2O3, and finally the formula of gallium oxide was also Ga2O3. So this provides a convincing proof for both correctness and usefulness of Mendeleev's table as a powerful predictive tool. Correction of doubtful atomic weights. When Mendeleev observed that a recurrence pattern of properties didn't match the order of atomic weights, he went with the properties, insisted that the atomic weights must be wrong. This helped in correcting some of the doubtful atomic weights of some elements. For example, beryllium was assigned atomic weights equal to 14, but there is no vacant space between the carbon and nitrogen to fit beryllium. After properly studying the properties of beryllium, what he concluded that the atomic weight of Be must be wrong. So after properly studying the properties of beryllium, he calculated its atomic weight was actually 9.4, not 14, and then he simply placed it in its proper place, that is between lithium and boron. Noble gases or inert gases basically were not known at that time, and they actually discovered much later. But one of the strength of the periodic table was that when these gases, helium, neon, argon, krypton, xenon and radon, were discovered, they could be placed in a new group without disturbing the existing order. Then there were some defects of Mendeleev periodic table. So although Mendeleev's periodic table was a great advance all over the previous classification of the elements, but it was purely empirical and has many defects and anomalies. So the first one was anomalous pairs of elements. There are a number of anomalous pairs of elements where the element with higher atomic weight has been placed before the one having the lower atomic weight. For example, cobalt, whose atomic weight 58.9 precedes nickel, on atomic weight of nickel is 58.7. Similar thing happened for tellurium, whose atomic weight is 127.6, but it precedes iodine, whose atomic weight is 126.9. Then grouping together some elements with dissimilar properties, so copper, silver and gold are grouped together with highly reactive alkali metals such as lithium, sodium and potassium. Similar thing happened with the grouping of manganese with halogens, which is not justified as they have quite dissimilar properties. So separation of chemically similar elements. So if, for example, gold and platinum, they have the similar properties, but they have been placed in separate group. Then the position of isotope was a very much bigger problem. So isotopes basically are the atoms of the same element having different atomic weights. Therefore, they should be placed at different places because the periodic table was based on the atomic weights only. So there has to be some different space for isotopes in the Mendeleev's periodic table. But however, isotopes have identical chemical properties, therefore they should not be placed at different positions. Then position of hydrogen was again a problem. The position of hydrogen in Mendeleev's periodic table is basically unsatisfactory as it has been placed in the same column with copper, silver and gold. In fact, hydrogen actually shows resemblance with alkali metals and also with halogens as well. For example, like alkali metals, it has one electron in its valence shell and forms similar compound. Here are the compounds of hydrogen basically, which is HCl and NaCl, then H2O, Na2O, H2S and Na2O. So it is basically actually resembling the alkali metals as well as halogens. Like halogens, hydrogen is a non-metal and exists as diatomic molecule which is in the form of H2. Then the last cause was it fails to explain the cause of periodicity. Mendeleev's classification of elements is purely empirical and it could not explain the cause of periodicity of properties of elements, that why this periodicity in the properties is happening, why the repetition of the properties is happening. I hope it is clear to you. Thank you.